Okay, welcome to part 2 of notes 5.2. So in question 6, they say we have these stacks of money here. We know that they all add up to 50, so if I drag these stacks in here, we know that their total is $50, and basically we're trying to figure out, okay, how much money is in each stack? And how do we do that? We go ahead and set up a little multiplication problem. I know I have 5 stacks. I know they each have a certain amount of D dollars. And I know that they equal 50. So basically, that is our equation. Now to solve this, we have to use inverse operations. Inverse means the opposite. So what is the opposite operation of multiplication? And that's obviously division. So to solve 5D equals 50, we're not gonna add 5 or subtract 5 from both sides. We're gonna divide 5 from both sides. That cancels out, and I get my answer. Oops, sorry about that. Of D is equal to 10. So each stack here was $10, and that makes sense. 10, 20, 30, 40, 50. That's how that added up to 50. I'd pause and do number 6 if I were you. Number 7. We have Angel asked his mom to make granola bars for his upcoming baseball game. He had 24 cups of oatmeal in the cabinet. The recipe called for 3 cups of oatmeal per batch. How many batches can be made? So let's figure out what we do know. There's not enough oatmeal for a batch. Well, that's not true because we have 24 cups and we only need 3 cups for 1. So we can definitely at least make 1. So that's not true. 24 cups of oatmeal left? Yes, that's a true statement. Each takes 3, yep. And can I make multiple batches? Yeah, because 3 can go into 24 multiple times. So there we go. So if I want to set up an equation, it'd be 3 times the number of batches I think I can make is equal to 24, the number of total. And I go ahead to solve this. 3b is equal to 24. I just divide by 3. Divide by 3. That cancels out, and b is equal to 8. What this is saying is 3 times some number gives me 24. What I just found out was that 8 was that number, and 3 times 8 is 24. I'd pause and do number 7 if I were you. Number 8. Andrew bought himself and some friends some coffee. They were $1.75 each, and he paid $7 for all of them. How many coffees did Andrew purchase? So if I wanted to write an equation, we know that he paid $1.75 per coffee, and we're using D, the variable they tell us right there. And we know that total was $7. So to solve this, it's just $1.75. D is equal to 7. And again, we divide by $1.75. It's interesting to note that you divide by the exact coefficient here, because the inverse operation is division. Here, it always looked like we were doing the opposite when we were adding. Because the inverse operation of addition was subtraction. So it looks like you're doing the opposite, but really you're just doing an inverse operation. And so just get that in your head that when you see that multiplication, you want to divide by that exact coefficient attached to the variable. So in this case, D is equal to 4. He bought 4 coffees. All right, pause and do number 8. Question 9. Isabel used an equation 4x equals 60 to represent a problem. Click on the appropriate quantity and drop down to complete the problem. So, Isabel's car had 4 brand new tires. There were X amount of cars in the auto shop for the same installation. Altogether, 60 tires were installed. So basically, that's our equation, right? 4 new tires. We don't know how many cars there are, but we know we installed 60. So to figure out how many cars there are, we just solve this. So we divide by 4, divide by 4. X in this case equals 15 cars. 15 cars, and if you did 15 times 4, you'd get 60, the amount of tires we did. So I'd pause and do number 9 if I were you. And the last question, number 10. Nicholas used the equation 26.2a equals 131 to represent a problem. That's 26.2 is the number of miles in a marathon. And so we're going to place this in the appropriate blanks. So Nicholas' uncle ran a marathons last year. We don't know how many he did. But we do know how long a marathon is. It's 26.2 miles. And we know his total distance was 131. So if I wanted to set up an equation, it's 26.2a, just the exact one they gave us. And to solve for how many marathons he ran, how many races he ran 26.2 miles, it's a really long distance. I just divide. So those cancel out, and I get a is equal to 131 divided by 26.2. He ran 5 marathons. That's a lot of marathons. Now, C goes a little bit further. He says, what if I told you he ran 24 marathons? What would his total be? So basically they're asking you, what would his total be? Well, we know one marathon is equal to 26.2 miles, right? So 24 is just 26.2 times 24. And if I did that, I would get, he would have run 628.8 miles. That's a long way to run in a year. Right? Okay, good luck on BuzzMath. When you're done, make sure you check your email and Canvas for recent ST Math minutes and grades.